Hey guys, we're out at the Strong Point Firearms Training Complex in Waverly Hall, Georgia on this beautiful 80-degree rainy day. And the topic of thermal drift came up. And by now everybody knows it's a physics phenomenon. Anytime you have materials that are dissimilar in contact with one another and they're exposed to extreme temperature changes, they're going to expand and contract at different rates. That's no different than your steel barrel extension in your aluminum AR receiver or the copper jacketed bullet in your brass case. What most people don't realize is, what effect does it actually have on your optics when we talk about it. So we're just going to do a really informal test that you're welcome to repeat at your leisure. We're going to take this HWS 518. We're going to take 3 rounds at a steel target at 50 yards. I'm going to pop it off. I'm going to stick it in this cooler full of dry ice. We're going to forget about it, go do a few other things, come back, pull it off, mount it back on the gun, and see where it hits. So let's see what it all means. Going hot. Should probably leave this open, that way it doesn't freeze shut. So we've got our handy little infrared thermometer. So we'll check this out. It says low. Maximum is -40. We're going to try to get this down to about -20. So let's come back and see what happens. All right, welcome back. It's been almost an hour, 59 minutes and some change. Temperature's still right around the same out here, about 80 degrees, dropped a little bit. Let's see what we've been able to get this sight up to. All right, so we're about negative 9.7 degrees Fahrenheit. So let's get it back on the gun, take another 3 rounds at the same target and see what happens. And it is deathly cold. Very, very cold. Yeah, it's real cold. I think the biggest problem you'd have going from 80 degrees down to it's -9 or 10 is going to be you living. I'm going to have to wipe the frosting off. Reticle's still nice and bright, but I'll be doggone if I could see anything through all the ice crystals. So I'm going to try to line it up, take a shot, wipe it down, line it up, take a shot. Oh yeah. Got a good clear reticle. Really hard getting the image, it's just frosting up so quickly. I'm just glad it's not a bolt gun. All right. We'll go down and take a look at where the hits are, but I gotta tell you, if you notice the difference, that guy didn't notice the difference. My EOTech's ready to handle anything we could throw at it. So, kind of know where the first 3 rounds were. Try to take a look and see if we can see if there's any changes in that group. Obviously, like I said, it's really difficult to see through because we kept getting the fogging. So I can't say for sure if my hold was exactly the same as it was on the others. It's a 50-yard target, so man. So I know for sure on those first 3, it was going to be this round and then the other 2 right here. And then so we're about right here. I got to say, it could be a little bit off hold. I mean, we know that there's thermal drift. We know that dissimilar materials, due to that expansion and contraction, they're going to move a bit. But we just took an item, our sight, we took it off the rifle. We took it from about an 80-degree ambient environment. We put it down on dry ice, which is right around minus 100. We left it there for about an hour, and we got it down to below 0 in that hour. I mean, that is a fantastic thermal shock. And one group to the next group, you know, and that's a dismount and one hell of a thermal cycle. Does it happen? Yeah. What does it mean? That